at night and on their night, our noontime. So please let me know what your areas of interest are so that we can tag people up for that. So, okay. Are you ready to explain the process for logging in, for registering?
Yeah. Let me mute myself here. Okay, so I don't hear myself talking in the headset. So yeah, pretty straightforward. You can scan the QR code. If you're watching on the stream, there's a link in the video. It's just going to take you to a Google form, fill it out with your info, and then once you submit that, you should get a certificate automatically kicked back that you can use if you want to do recertify by points. And then the process to do that's pretty straightforward. I think it's linked in both LinkedIn and the NI forum for the user group. There's a document that has all the links that you need, but I can also provide that outside of this. I think, let me see if I'm logged into Drive right now. Yeah. So yeah, this is the one that's linked in there. So this will give you a link straight to the submission form, and you can use the certificate that this QR code will provide as part of that submission process. This is all, like I said, this is all linked in all of the, both the NI forum official page and the LinkedIn user group page. If you can't find it, you can always email Hamilton or myself or post to the forum or whatever. That's pretty much it.
To fill out the individual form that says whether you're an attendee or a speaker or online. So to fill that out separately?
Yeah. Yeah. Every person who's trying to claim recertification points would fill that form out and then attach the certificate as a part of that process.
And speaking of, I did not line up ahead of time. I would like to do this ahead of the meetings. We do not have yet anybody tapped to be the organizer for this meeting, which is basically somebody who submits the list of attendees. So is there a volunteer for getting 20 points toward recertification? Yeah, we're pointing to Mr. Foster.
I did it recently, so I don't want to be greedy.
Venkat, you haven't been organizer in a while, have you?
No, but I'm actually not certified.
So. Okay. All right, so we're going to skip over that one. If by the end of the meeting you let me know, otherwise I'll just figure something out. Okay, today we're going to talk about TestStand. I know that a lot of you guys use LabVIEW, and I assume some of you use TestStand. Some of you are more qualified to give this presentation today than I am. So why aren't you up here doing this? Today we're going to only talk about the baby version of TestStand called the Sequential Process Model. And what I want to do is just kind of give you a flavor of what TestStand development looks like for the Sequential Process Model. And somehow, there we go. Okay. So basically what we're going to do today, we will talk about the 3 different process models that are baked into TestStand. You are not restricted to those 3. You can actually bring your own in, but we're not going to talk about any of that. I'll just show you what kind of some overall differences are between the sequential and then the parallel and batch process models. We'll walk through just an overview of what the editor looks like, and then we'll kind of go through several pieces, among which are the callbacks, which I'll explain in a little bit. Then we'll cover variables and parameters and properties, how they're used, and then a wrap-up. So the different models are sequential, the parallel, and batch. And this sheet mostly is for reference because it really it's a little eye glossing over. But basically the sequential, you're just running one test at a time. And so you go from beginning to the end. And the parallel and batch mode are used for if you're testing more than one unit at the same time. We could call that more than one serial number at the same time. The parallel, it does do concurrent testing, and so you have parallel execution paths. The batch mode is like the parallel mode, but you get to synchronize operations between different what are called sockets or test paths. I guess well, why did I just put that one there? Okay, this is just, yeah, I know why I put it there. So this is kind of from a 10,000-foot view what the sequential process model is. Everything here in the red in the middle, those are callbacks. And a callback is effectively a piece of code that is used for a specific spot in the sequence. And this does not cover all of the callbacks. It just covers the basic ones, I guess you might call it. So before you start the process, you do things like ask for a serial number. That could be scanned from a barcode scanner, or it could be typed in from a keyboard. That's one of the things that could be done in the pre-UUT step. I honestly did not look into what the pre-UUT loop is and the post-UUT loop is to know what the difference between that and a couple of other callbacks. There's one called process setup and process cleanup. So I didn't get down into the buried of the details of it. I'm trying to give an overview of the general development process, if you will, using the sequential model. And then it's showing you that within the pre-UUT, you have a piece. I should ask, is everybody able to see all of this stuff pretty easily? Within that is a set of code called setup and main and cleanup. So these are sections of code that happen for each of the callbacks. And that describes, you can see the sequential is basically for a flow. There's no parallel. Of the others. And if you'll notice, to the extent I have a socket that controls the flow for a unit. And by the way, Venkat, if I say something wrong, I want you to pipe up during the presentation. And so this is something I didn't know is in the parallel process model. These units are so independent that they can actually start and end at will. And so you can actually have a particular serial number in each socket, if you will. You might think of this as a fixture or a nest for each unit. And if one of them completes, you can actually start the next run, the next serial number, before either of the other two have completed. So everything is pretty well independent of everybody else. And in the batch synchronization, this would be useful, for instance, if you have a palette of printed circuit boards that you're testing. And so you may put you may have a little printed circuit board and it's palletized on a card. So you have a big board that has a lot of little UUTs in it. You put it in and they all start running at the same time and they all finish at the same time. So you can see that the report generation, for instance, differs between them. In the parallel model, you have the report being produced for each UUT, but when they're batched, the report is generated for the batch. There are other pieces that are involved for either of these models that we're not going to get into today. We're not talking about these. I'm just letting you know what's there. I guess I should ask, are there any questions at this point? You can stump the presenter. Okay. Now I'm going to walk fairly fast through this because I want to get to some stuff in the software, but I just kind of want to give you a flavor of this is the editor, kind of what it looks like. Over on the left side, you'll be able to select different views to see, for instance, the view I've selected, you get to see the different step types that you can add to a sequence. This is the view of one of the callbacks. So we're looking at sequences now, and I have defined some of the callbacks. The callbacks, and I haven't gotten into callbacks yet. I'll hold off on that. But these are sequences, some of which are callbacks. We'll get into that in a minute. And then when you select a step, you actually get to see the details of the step, both for if it is a call to something else, you get to see all of the information about that call, and you also see properties for that step. And you basically it can have multiple sequence files that are participating. I'll go into that. Honestly, at this point, I'm not ready. I want to go farther before we get questions on this. Oh, I should say up at the top of this is a menu, and this is how you interact with the TestStand development environment. Okay. For the sequential process model, we're going to configure station options. Honestly, if you install TestStand, it's already set up that way, but I'm going to do it just to run through what is done to call up a sequence file, a sequence model. If you can have the station defined for one process model, but you can define which sequence model to use in the project that you're working on. And so the station options we will see in a minute, but this is what that looks like. And it says use the station model, allow other models, and we've chosen sequential model. The second one, the sequence file options, there's a the station, we can use the station model, or we can, so this one, there's another option here to use station model, but we've chosen to use a specific one, of which sequential, batch, and parallel. So we have options in how we configure to run the models. Okay, we will again walk through this, but just honestly, these slides are a little bit for reference so that you can go back later. Will tell me where to put these at the end so that y'all have access to them. But you can see up here on the left, I have tests, and under tests, I have pass-fail, which is kind of like a Boolean. Numeric, there's a multiple numeric limit, which I don't think I've ever used that one, but it basically allows you to define sets of ranges instead of just a single range of acceptable values. And then a string value test. Also, there's a section called flow control, where if we expand it, you'll see these. There's an if, else if, else if, and then of course it has an end associated with it. For and end for each. While all these loops, you can do breaks, you can do a go to. Anyway, so these are kind of different step types that we can use within TestStand. Okay, additionally, we can call a subsequence. Now, you don't typically call into a callback, which I'll explain a little bit better what a callback is in a few minutes, but those are called by the process model engine. But you do not have to have all of your code. The main sequence does not have to be the entire sequence. You can, one area that you might want to have this is not a National Instruments word, subsequence. That's my word. So it's basically a function. You can call a function, and you might use that for a set of code that you're going to reuse. So, and you can call a sequence that lives in another sequence file, in addition to calling one that's in the current sequence, and you can pass parameters between the sequences. Okay, so now we're going to get a little more involved in the model callbacks. Do you see the different colors? These mean something. The green ones are the process. Let me see. I can go forward one, I think, and yeah. So if I remember right, it's the blue ones that are the engine callbacks, and then we have model callbacks. So engine is basically TestStand, the runtime, and then within the model you have different callbacks. So these are all available to the sequential process model, and yeah, these blue ones, if I remember right, are engine callbacks. I don't remember the test UUTs in single pass what type they are. But anyway, this is the complete list of callbacks that are available for the engine as well as for the sequential process model. And they are not listed in any order. There is somewhere, and I don't think I've even listed an order of execution of these. No. There is somewhere a list that has a partial set of callbacks, but that was not easy to find. For the purposes of today, we're just going to work with some that are sort of standard and easy to deal with. So we won't worry too much about the ones that we don't know where they belong. Okay. From the editor standpoint, you can see over on the right, we have included callbacks for the main, for pre-main, for post-main, pre-UUT, post-UUT, for the setup of the whole process and the cleanup, as well as these are engine callbacks for the sequence file load and sequence file unload, which basically these are executed when you load the sequence file. So it happens once when this sequence file is loaded. And I've kind of just drawn a connection between the list that we saw on the previous page and what we see on this page. So this thing called pre-UUT, is that one over here? No, but we do have the main sequence is shown here. We have the sequence file load, which is here, and then the sequence file unload. Okay. The other thing I wanted to talk about before we dive in is variables, parameters, and properties. And if you just lump these together, it's just things. These are objects that you can reference. And I've given over here on the right the different places that variables and parameters and properties live. So we can have locals. Locals is a set of variables that are specific to a sequence, and the scope of them is that sequence. So they're not available outside of that. And when I say sequence, I mean a function. So it's not the sequence file. It is one of these over here on the right. The parameters are used to pass information between sequences. And then the file globals are variables that are available the sequence file. So for all of the sequences that live in a single file, the variables have scope and are available for use for any sequence, including callbacks and ones that you define within that file. Station globals are global to the complete computer. So that's basically anything that you might ever run. This context is basically properties about what's going on, and run state additionally describes execution. So those really are things that are available while you're running. We're not really going to talk today about the context or run state very much. In fact, maybe not at all. Are there any questions so far? Please.
They are not, say, this place,
Which means that when you load TestStand, they are available until you close it? Yeah.
But if you make any changes to the value, you'll persist across. Next time you open it, set variable will be back to its default state.
Right. So it's basically, it's not when you close your computer, but when you close TestStand. Okay.
Or you close the sequence file, close the execution.
Yeah. Okay. Thank you. Oh, okay. Well, now we get to dive in. I've already started TestStand just to make it take a little faster. You're going to be presented with a screen to log in. And this is a feature of TestStand that allows you to track not only what you tested, but who tested it. And so it comes by default with a user whose name is administrator, and there is no password. And that's how I typically leave it and let the customer set up how he wants to for his users. So I just press OK, and now we're in. I actually opened this by opening a single TestStand sequence file. And that's what we're going to work with today. There are projects and workspaces. I'm not really going to get into the distinction of those because I wanted to focus more on how we build sequences and what kinds of things we can do with them. So as you notice, we have our green callbacks. These are the process model callbacks, as well as the blue, which are engine callbacks. I don't know what that one is even. I said it wrong. Thank you. Thank you. Yes. Thank you for correcting me. This is an engine callback, the pink one or purple or whatever color that is. These are ones that I created. These are what I would refer to as subsequences. Thank you. Okay. So when your execution starts, of the ones listed here, the process setup will happen first. And that happens once, followed by a call to the pre-UUT. And this is where you would typically enter the serial number that you're going to test. And it's the purpose for having it here is if you want to abort, you say, I'm done testing, you can basically cancel out without entering a serial number, for instance, and have it close out the execution without building, for instance, a report. And we'll talk about reports in a little bit. But the pre-UUT is before each unit is tested. The process setup happens before all of the UUTs, including the first one. I have commented out the default pre-UUT, which is a built-in, it's a process model widget. It's a dialog that prompts you to enter the serial number. But I'm using my own, so I disabled that one. And I have several things going on. One is, if there was a test that already happened, I am going to stop it. I'm going to, Basically, I want to abort after every UUT so that the operator can look at the report. This is not something you would normally do. This is something the customer, how he wanted it to work. And I have it where it clears the, so we're not only going to ask for a serial number, but we're going to ask for a model. So what model you're going to run. And then did it crash? We're going to let people know about that. Here is kind of a little more advanced topic. You can actually run a VI in the background while everything else is going on. And then we actually have a wait, and we're looking for a specific condition. I can't. I'm drawing a blank. I'm sorry. Yeah. Anyway, we shouldn't really worry about this one. Wait until system state is running. Come on. Yeah, I don't think it's that one. You know what? I apologize. I'm not even reading my own sequence. This is a label. This doesn't do anything. This is just telling me what is getting ready to happen. It's just a comment. And so here I'm actually waiting for a second. And then I'm checking system state. And in this case, it will introduce me to a module. In this case, it's a LabVIEW module, and it is an async VI state VI. And I'm not really at the moment, we will be talking about calling into LabVIEW, but that's not right now. That's basically a module. And I'll explain that a little more in a little bit. And so if the state is running, if the state is not running, then we're going to go back and check the system state, and we're going to keep doing that until the system state is running, at which point we then start monitoring the digital inputs.
Can I add something?
Yeah.
We were probably, most of us talk that go to the good bad, pretty well kind of even tested. Just a list,
Okay. Yeah.
list of available commands. Probably going to end up using go-tos.
The real nice thing about go-tos is that you can bypass a lot of things. So if you get a failure, for instance, and you can go straight without using a go-to from a failure, but there are places that you might want to, and this is the place I want to go, is the thing called cleanup. Do you remember early on I said you're going to have a thing called setup, main, and cleanup? Each callback has a setup, main, and cleanup. Basically, the go-to cleanup allows you to bypass the rest of anything and go straight to what's going on in the cleanup. It's just a quick and dirty way to skip over everything else that's going on in the main part of this callback. Okay, and I'm going to slowly through this. I'm not really wanting to walk through this whole callback. I just wanted to give you the flavor of, we've got steps. Those steps are selected from over here, and we can just drag one over and insert it at will. You can actually select a whole bunch. I'm out of sequence here. You can actually select all of them and disable them all as a group, or you can cut them and paste them into a different place in your code, or into a different sequence, or into a different sequence file. So it's pretty nice for being, it's a nice, well thought out editor. Yeah, I jumped into this. I was actually supposed to start off by showing you some configuration, which I did not do. And I told you that there's a way on the station options to select the model. So by default, we're going to use the station model, but we will also allow other models. The station model is selected to be the sequential model. That is what is chosen when you first install TestStand, and so you probably want to leave it just like that until you've got the sequential model under your belt and we're ready to move on to the other ones. The other thing I mentioned is that is the sequence file. You can choose to use the station model, or you can require a specific model of which you can choose sequential. So those are the two methods of choosing sequential model. Okay. Another thing, this one you might want to make note of. Yeah, I see Rich is not going to. Rich, close your ears. One of the early things I would recommend is setting up some search directories. You really don't need this until you're deploying, but when you're ready to deploy, you're going to say, why is it not working? And it's because there's a step that you need. Anybody tell me which of these paths points to a LabVIEW installation? This one? It's TestStand. If you get anything out of the JKI, the VI package manager, potentially things out of VI package manager, the point is those are not in here. And it was not until this week that I learned that. I've never before the most recent project we did done a deployment. We actually ran from the development machine. And that was sort of a showstopper that really tripped me up. And one of the field application engineers, after he walked me through it, and I said, oh, he said, well, I've already told you that 5 times. Here's the problem is that you don't get to see that until you make that really wide and notice that there's nothing in here called LabVIEW. So basically what we want to do is add 2 paths, and those reference the installation folder for LabVIEW, which is under National Instruments. In this case, we're using LabVIEW 2023. We want 2 folders. We want user.lib and vi.lib. So that's one of them. I actually want the current folder. I'm going to move that one up because I want it to be searched first. And then the other one that I want to add is the user.lib. And one other piece with that is that for both of these, you'll notice here, this one says look in subfolders underneath the current sequence file directory and in some component folders as well. You could select to look in the subdirectories for all of these specified directories. But when you do that, every time that you do anything, it slows way down looking in all of those subdirectories, especially, for instance, Windows System 32. You don't want to look in the subdirectories under that. But this right here was a thing that tripped me up quite a while, and I'm putting some cookies on the bottom shelf for you. If you ever encounter it, you're welcome to send me an email saying thank you. But I found that to be a very important piece. So, and I think I finally figured out why they didn't include them. I think, and this is a guess on my part, is that you can use multiple versions of LabVIEW at the same time. I highly recommend against it wherever possible. There may be deployment systems that require multiple versions of LabVIEW running on them, but if you can avoid it, I recommend just sticking with one version of LabVIEW. Okay, let's see. I want to jump into a section, and this is sort of from an overview standpoint. I'm doing this a little out of order because I did go down into the editing prematurely, but I want to talk about debug. And so there's this slew of menus that, what's under each one. Well, we'll get to some of them, but there's this thing called Sequence Analyzer, and there are some options we have. And honestly, I don't really care to analyze skip steps. There may be a reason I skipped it. Maybe I'm not ready to use that one. Maybe I don't want it to report a problem. But I do want to analyze subsequences, because if I analyze and everything checks out okay, and then I run it and oops, I didn't analyze the subsequences, it's going to be runtime when I find a problem. There's another one. I've always used this one, analyze before executing. And that's great when you're in a development and debug stage. When you get into deployment, you'd rather not have to, once you've got everything the way you want it, you might want to turn that one off, which it's turned off at the moment. Then there are rules, and we don't really get to do anything with the rules at this location. There is, and I don't know if we'll ever cover that today or not, that's not important. But I'm going to go through the analyze portion. So you're going to see that it's going to analyze 9 sequences. This includes the callbacks that we have defined, as well as the subsequences. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything is in my one sequence. This may or may not be a good design for your project. There are a lot of projects where you're going to want to use common code. You want to do code reuse. Using multiple sequence files is a very good idea. This particular one, it worked really well not to. When it's completed, here's our analysis results. Your computer is going to have a higher screen resolution, so you'll be able to see more at the same time. It's pretty small to look at up there. It'd be worse if I had this where you could see more things at the same time. This sequence, actually, everything works. This says the variable should be used. I'm not using that one, that one, that one, or that one. Honestly, I really don't care. And I can hide those warnings. Or they're not even warnings. They are actually informational. There are analysis results that you can enable or disable. You can hide things that you don't want to see. There's another one here that I really don't care about. I don't mind seeing it because I don't have so many of them. One of the field application engineers told me that he makes serious use of file path expressions, where he builds the file path on the go. And if he does it within TestStand, TestStand lets him know about it. So he usually disables that one. This one came up with a clean bill of health for all 9 sequences. So we're good to go. Okay. We talked about callbacks. I'm going to show you how easy it is to add a callback. So we've got variables, we've got sequences. The callbacks live in this area. We can add a new sequence, or we can use callbacks. The sequences are the blue, the callbacks are green. I should say this is also a callback, it's red. We can just right click and create a new sequence. We can also, these that are checked are the ones I'm using. So we can see a lot of opportunities for adding. We can even, and I've actually used these for modifying stuff about the report. Those are actually useful. There's one called test report. And so we can actually, let's see what that, I don't remember that one. I don't remember much about it. So here's one called test report. That's a callback. It's a process callback because it's green. And this one says call test report in case the sequence is being called directly from a client. Okay. So this is basically a sequence that's defined as part of the process model. And it has settings. We get to tell these parameters are being passed back and forth. And in our case, they're being passed in. So we can pass into the report the UUT, and this is everything about a UUT, which includes its serial number and anything else we define. We've got some report options and stuff. Pretty cool what you get control over. It's very flexible. I'm going to delete that one because I don't really want to keep it in there. I was just wanting to show you how to add a callback. To add a sequence, we just say new sequence. We can name that sequence dummy sequence. And we get to see that the sequence actually has a setup, a main, and a cleanup, just like the callbacks do. And so you could think of it, you can just for simplicity, just use everything in the main if you want to. I mean, there's no reason to build out a setup and cleanup unless you want to do that, go to cleanup as an example to bypass the rest of the sequence, the rest of the main part of that sequence. Okay, so that's adding. I want to cover, we did cover variables and properties. For this one, I'm going to go ahead and get rid of that one. I don't really make a lot of use of locals. You can see I had one here called software killed. I made use of something in my, I have a VI that basically lets me know when the LabVIEW stuff that I'm doing has finished. But I made, in this project, it's not always that I do it, but in this project, I actually used file globals because this customer is going to have a deployment license for TestStand, and the mechanism we are using for defining step limits, I should have told you about limits and stuff like that. But basically, we read them in from a file. And so we're passing them between, we're not passing, they're available to be used for any sequence. And that was just sort of an easy way to make them available to every test sequence, if you will. In addition, I have defined things like the unit model, the unit serial number, what its voltage level is, like if it's a 480 unit or 208 voltage unit, that kind of thing. Okay, and the other thing I did is I actually have a LabVIEW VI running in the background looking at all of the discrete inputs from the machine. So for instance, there's an e-stop. So basically I have an asynchronous VI updating the value of all of the machine digital inputs. And I think it's like every 10th of a second or something like that. And I make those available to every sequence as well. That way I don't have to call a VI to, I call the VI one time and I forget about it and I just deal with the inputs where I need them. In this case, I actually needed to keep up with the one called eStop because I needed to be able to process that, and I did that asynchronously. Okay, now, so I did that because everything was in one sequence file, and so all of those the scope for them is this complete file. So everything is available to all of the sequences, including the callbacks, which made it real easy to deal with. You do want to be careful with scope in the sense, from a programming standpoint, you want to make sure that things that you are, objects that you are working with are available where you need them, but not in places that you don't need them. And additionally, things that you might have a conflict where if you have a variable being used that has one meaning and you have a variable that's very similar to it that has a different meaning in a different context, you want to have separation. So I'm not really wanting to get a deep dive into that. I just want to let you know that you have the opportunity to build up scope where you need it. And the locals, the parameters, and the file globals allow you to do that. Okay. Because I jumped ahead and we went through it, we talked about some step types. So we have test types. Those we have down in a test sequence. This is a subsequence that is being called from the main sequence callback. And I want to show you that based on the model type, so we have if the one model is present, we're going to decide if it's a 408 or 480 or 208. And then we're going to call the test sequence for that type of model, the IC model. We have a heater model. So else, if it's not an IC, then it's going to be a heater. And so we have a different test sequence. So we have two test sequences, one for the IC, the instrumentation compartment, one for the heater. And so these red are tests. The L is an action. It doesn't produce a pass-fail. But the reds produce pass-fail. And so that's the test types. The test, what do we call it? Step type of test. We've got a test type of action. I've never used the FTP, or I think I've ever used additional results, but you can call a sequence. So we showed that here a minute ago. In our main sequence, we just drag this over and make our call. We can make a statement. A statement is an expression where you can just make a definition. It even tells you what it is. We've defined the unit voltage to be 208 as an example. Property loader, that is a little bit of an advanced topic. That is where what we could have done with our limits is load them within TestStand. I found that interface, it's an excellent, you can use different file types. You can use, Excel would be a standard type, but even in Excel, it was hard for me to think in the mind of a customer and how would I use this file to edit my limits? And that's why we loaded them through a VI. Yeah. So anyway, a label does nothing, but you can go to it. It also is a decent way to set up for just describing what's happening here to the operator. You can do a message pop-up. You can call an executable. We get back into the flow control where these are just basic programming capabilities, I guess you'd call them. You can do synchronization of where we're waiting for things to happen. And in that case, we've got some of those. I can just show you a wait. You can wait for a time interval or a thread or different things you can wait on. Batch synchronization if we were doing batch. And then there are LabVIEW utilities. That's where you would call a VI asynchronously, for instance. Anyway, so those are the step types. Are there any questions covering step types? I know I went through that a bit disjointed and quickly.
Comment I have is called creating other step types. We have different adapters for that.
Thank you. Okay, great. Back up here on test types. The fact that it has an L references a adapter. So under configure, the default adapter is LabVIEW, and we can configure it. For deployment where you do not have a LabVIEW development license, you would come up here and choose the engine. For the deployment of this one, I chose to use the specific one. We only have one version of LabVIEW. These, I don't even know why they brought them in. They have to do with something else. Who knows? But you can do the auto detect. I didn't when I deployed. But for now, we're using the development. So that covers that. But you do have, when you bring in a test type, a test step, I should say, under properties, you can tell it a different adapter. You're not stuck with just LabVIEW. So you can do Lab Windows. Who in here does Lab Windows? Lab Windows? No LabVIEW ticker? No, okay. Lab Windows? All right. C, C++, I'm sure some of you have ever done that. I do .NET. There's actually a keyboard. I never have found a good LabVIEW on-screen keyboard. I found one, it had bugs in it. I'd already built one in .NET. I said, daggum it, I'm just going to stick with the one I've already built. So that's what I do. I wrote a LabVIEW wrapper around, and I could have just brought it in directly, but I've got a LabVIEW wrap around it. You got Python, or you can use none. But anyway, those are your options for adapter sources, if you will. And that's to what Venkat was reporting. You actually can tell it different kinds of places to go, different code types to work with. Now, are there any questions? Under adapters, for instance. Hey, where's Rust? COBOL? Fortran? The best way I would say it is probably, I don't know this, but my wondering would be if Rust would be like a C++, but I don't know that. Several things you can build up as a C++. Any other questions? Moving along. So we covered modules. The thing we didn't hit on modules, because that was actually what I was hitting next, is we get to tell inputs and outputs. So the things that are called in are inputs to the LabVIEW, and the things that are out are outputs of LabVIEW. It is my typical to always use for a LabVIEW call. Well, this one didn't have one. Most of the time, most of my LabVIEW have an error in and error out. So I don't pre-populate the error in, but I bring the error out. Do you see this thing called step.result.error? That's a built-in LabVIEW. So it actually populates that for me. I don't have to tell it to put the step.result.error to take. This is basically the LabVIEW output, and it copies it, I would call it, into the step.result.error. Additionally, I bring in some inputs. This was actually so I could run here today without equipment. I don't have my instruments. There's a channel number and some Skippy type options. I can use the default, or I can tell it the ones I want. And another input is what is the file that I'm going to be using. And in that case, I'll show you that I have these scripts. So I've got a 4-wire resistance script. It's supposed to let me do that with Notepad++. Okay, but anyway, basically these are Skippy commands, and they are to reset the instrument, configure for 4-wire resistance, delay a half second, and then this is something I built. And so then read from the instrument and reset the instrument. And these %1, %2, %3 are kind of like your command line batch files for Windows. %1 is your first argument, %2 is your second, %3 is your third argument. Questions? Okay. So these are the inputs and outputs to LabVIEW. And another thing about LabVIEW, I've already opened up my project that we used for this. This is my project, and these are my individual VIs. One of the things, and I don't have a straight answer on this, but if you run into problems, there are a couple of things. Under project properties, one of the things on the internet indicated, do you know that you can separate compiled code from your project sources, like your VIs and your controls? All right. It is my normal practice to do so. Does anybody know why I normally separate them? Exactly. Exactly. When you touch a VI, even if you don't compile it, it updates the timestamp. I didn't want you to do that. I've read some stuff on the internet that indicate that TestStand may prefer them to be together. And so what you get to do is you can highlight everybody and see that says unmarked so that they are not separated. So your compiled code is in the source VI as one unit. Okay, and so that for this I did not separate them, which is not my normal for LabVIEW. The other thing, and you cannot do it from within the project because the project is loaded. So as soon as the LabVIEW prompt comes to us, I am going to go to Tools, Advanced, Mass Compile, and choose the folder. This is my LabVIEW folder, sir. I can't hear you.
I've been through this hell before.
Okay, and so I'm going to tell it, I'm going to use the current folder. I'm confused there. Choose the directory to compile. I just did that. Okay, so it's pre-populated that, and I'm going to compile it. It'll take it a minute. But what it's doing is it's going through and compiling every VI, including the dependencies, to LabVIEW 2023, quarter 3, patch 7. This is my hope that TestStand does not freak out and say, I don't know which version of LabVIEW you're using. At the end of this, it told me skipping a project that was in memory. It was in memory because of TestStand. So it did not compile everything. I'm not going to do it again. But basically, I walked you through the steps of what it is to compile them. Okay, now I'm going to open that project again and just show you. Almost all of the top level VIs that are being called by TestStand are in this folder called test functions. And so, for instance, there's one called measure resistance. The reason that it's showing up as running is because TestStand has it open. And so you can see here that while I'm running, it's telling me the path to go get I showed you where it does the star reset. It does the configure of the channel to do the 4-wire resistance and all that. What file, where is that file? These are the options that come in, the channel number, the range and resolution. I replace in this file the %1 with the value from channel, the %2 with the value for range, and the resolution is replacing what was argument number 3. And then I send those instructions to the instrument and I get a response back. Okay, that's just kind of a walkthrough of calling modules. I did not talk about limits. Here's where we define, in this particular case, we're doing a comparison. We want to know if there's continuity. Continuity is defined as less than 3 ohms or less. And so we said we want it to be, in this case, no. In this case, it's non-continuity. In that case, is it 100,000 ohms or greater? So we've got a greater than or equal to. And when we have greater than or equal to, we cannot even specify a high limit for some reason. I don't know. That is the low limit. But on the converse, when you have I want to see that it's less than the high limit, it doesn't give you that as a high limit, it gives you that as a low limit. That's just an idiosyncrasy to me of LabVIEW. The data source is step.result.numeric, which means that over here, I need to associate an output with that variable. Step.result.numeric is what it's going to use to determine if that number is less than or equal to the continuity limit, the 3 ohms, then it passes. Okay. There are, and I'm kind of out of time here, so I'm just going to whiz through this, but in addition to module, limits, data source, there's properties. You can give this a descriptive name so that your operator, when he's looking at it, it makes sense, or for your, within your report, it makes sense. You can turn the run mode to skip, or you can force it to pass or force it to fail. I always just leave it to preload when the execution begins. I don't know if there are reasons to consider otherwise. I don't ever bother with looping. With post actions, if it fails, I'm going to leave. I'm going to quit. You can actually set that as a configure. I think it's environment. I'm not positive. If it's not here, no. Pardon? Okay, thank you. Configure station options and immediately go to cleanup on sequence failure. And since that is a station option, I don't want to define that for every sequence that I might ever run. So I tend to do it within the sequence itself. You can actually set up expressions for pre and post. This is actually done for me. It's just something that's in the system. Additional results basically allows you to add results to your report and for your data collection. I'm not going to touch on that other than let you know that it's there. Okay. Over here, when you make serious changes to your LabVIEW or whatever your adapter, you can update for LabVIEW. I will give you some hints. You can do it within the sequence, the directory. If I had a workspace, I could do it for all files within the workspace. This is what it always chooses. So you actually, if you want it to reload, you have to tell it every time you hit this box. I'm going to update them, and it whizzes through and it looks to see if there are any changes in the LabVIEW that would affect the test sequence. And in this case, it would tell me that it was already up to date. So all of these look like they were already up to date, in which case it didn't do anything. Okay. All right, I want to cover 2 things here, and yeah, this is the last. Okay, under configure result processing, these are important considerations. One is for reports, one is for database. And these are the wrench. This is the wrench for making adjustments. Basically, we can tell it if we want XML, a text document, an HTML. These are kind of a National Instruments thing, I think, aren't they? I'm not sure what HTML is. Thank you. But I did find for what we were doing that some of the options did not work. And I'm not going to get into that. That's a more advanced topic, but it was ugly. What I was working on was ugly. But I want to show you that you can tell it where to put the reports. Reports, I'll show you a report. In fact, let's run it. I want to run it. I'm going to run it, and then we'll look at a report. Okay, now to start with, things don't fit on this huge resolution of a screen. Oh, no, it didn't do that. Shoot, it's not going to let me run that to conclusion because I don't have the biometric input. Let's see, where are we? Right here. Sorry. If I go to my pre-UUT and I am going to prompt to run gold, enter gold. I'm going to comment all this out. Enter gold, enter gold. If is due soon. This, by the way, to me, following the ifs through and the, to their end ifs and stuff is a little tricky. So I've got an if else end if and an end. Now that end is associated with this. If file globals dot run gold run. So this is something they do at the beginning of every day, is they run the gold. Sir.
You just not change the gold unit to,
I would have to do it with an assignment because I'm getting that from a call. So I can do a statement here. That'd be wonderful, right? Put it in the wrong place. My statement is file globals dot run gold. I think I can, nope, won't let me do that. Might be, there. Dot run gold run equals false. I can check and make sure that that's a valid statement. Okay, that should handle it. I'm going to save it and run it. Okay, now what I want to show you, this is my little thing off to the side that shows me all of my digital inputs. And I'm going to scan in a model serial number, 1, 2, 3, 4, 5, 6. I'm going to select the model that I'm running. And now we went from pre-UUT, now we're in the UUT running, the main sequence. And we have a unit there. And so now this is actually, this is actually what they would do. Something failed. But the cool thing is I've got a report now. That was what I wanted to show you, is the report. And so we now have a PDF of that, and the report tells me that the sequence failed, and we're going through this pretty fast, but basically I loaded the UUT, and then I went into the test sequence for the instrumentation compartment. I told it apparently an incorrect fuse type. Oh, I did. It was supposed to be FNQ-R. And I typed it in wrong. If y'all bear with me, I'll do that one more time. And if we get there, we get there. 1, 2, 3. 1, 2, 3, 4, 5, 7. This time, I hope my fingers work. Okay, I'm loading the UUT. Now, FNQ-R-5. Did I type that correctly? Now we ask, yes, I've got that step done. FNM-12 tells the operator some things to do. These are LabVIEW VIs that I built so that they make them bigger than the stock TestStand ones. It tells me to do something, and then it made a measurement, and now it tells me some more things to do. It's making some more measurements, and all of those tests are supposed to pass.
That's kind of dialog box.
Louder?
The TestStand dialog box, you can change the font size.
Okay. I also made one for a list box. You saw me where I selected the model. I selected it from a list. That one passed. It tells me to remove the UUT, and now I have my report, and the user gets to see that's interesting. It didn't work. It didn't load something correctly because it was supposed to be comparing real numbers with real numbers. Anyway, I'm not worried about that. It was just a demo. Apparently, it wasn't worth y'all's time for me to do that extra step of making it work well. Okay, but with that, we get report processing, which we just showed, and we get to tell it where we want those to go. As well, we've got database, and what I want to show you there is the built-in, there is an access interface for logging results to a database, and here I'm telling it what database, so you can build up a connection string telling it where you want it. You can even test the connection and all that type of stuff. And even if you don't have access loaded, you can look at the data. And that's a useful feature for a computer that does not have access on it. And it's loading that, I think, supposedly. There we go. And here's the access engine, and I get to look at my tables. And so here I can view the UUT result data. There may be some results in here, I don't know. Yep, we did some tests and got some results. How meaningful they are, you know, that's up to you to figure that part out. But anyway, you get to look at the data. That's pretty cool. It is that easy to log data to a database. Okay, we have gone through everything I intended to cover. We did not do it in as effective a manner to make it digestible to you, and I apologize for that. Now, are there any other questions? Go ahead.
No.
Okay, my intention was not to show you how to do everything as much as to show you the places you will touch and what they mean. So there are a lot of things we didn't touch, like source control, for instance. We did analyze the execute. Basically, you can execute in different modes, which is useful. I will tell you, for deployment, when you do not have a license for the development of TestStand, there is for each of the models, there is it's a LabVIEW user interface is what it is. And I'm going to run it here. Will it work? I don't remember. Well, I've made directory kinds of things. This is what the operator would see when he does not have a TestStand development license. And in this case, it will actually start the sequence running. So again, he has to log in. And no, it didn't. I don't have things set up correctly for it to, but this is what it looks like, and he would actually see this thing run. Okay. Will is going to get me to where we can load that, and I'll shoot you an email. All right. I want to give a quick question. Has anybody signed in for today and had problems? that was the last thing I wanted to show you is the slide. I've got a slide here, slideshow, start from current slide. This is what we covered, supposedly. I wanted to show you how flexible it is. And you get this authentication authorization with the login stuff. It's really nice. There it is if you haven't done it already. And if you hit that link, it'll ask you for your email and stuff so that we can build up for getting you recertification by points. One thing that I would like for us to do every month is if anybody as an employer says, hey, I need some resources, I need some help, I need employees, contractors, whatever. The other one is if you, and I know it gets a little tricky when we have people in the room, so it might not be, hey, I'm looking for a job, I've got one, but my employer is in the room and I don't want to let him know, so we can do that later if you need it. But if you are without work and need employment, hey, this is who I am and all that. So number one, any employers, I have seen before where SAIC was looking for people. Is, for instance, SAIC looking for people, or is anybody else in the room looking for resources, people? You're good. Anybody else looking for people? Then the other one is there anyone? Sir? Okay, so the answer is not really. You're already through the first part, or you want more? Does that mean it's still open for people to sign? Okay, so he's looking for people. This is SAIC. If you talk to Will, if you need something. Anybody looking for work? All right, we're done. Please let me know if you've got a topic of interest, one that you want to do or one that you want somebody else to do.
I could probably sign up for continuing on the TestStand topic.
Talk to me up here.
If you don't find it, I could do